Hello and welcome to another Math Micer video. These videos are intended for people who are in my adult education class. If that's you, great. I'm glad you came to catch up on a class that you might have missed. We are preparing for the high school equivalency test, whether we're taking the GED or the HISET. And if somebody misses a class, the easiest thing that they can do is go on Khan Academy and look up the subjects and do some practice, or they can open the Kaplan book, which is a great resource, and practice there. But a lot of my students just want to know what did I miss in class? So this is exactly what I would do in class, except of course in class it would take longer because we'd have lots of interesting conversations and some fun sidebars and things like that. If you're currently taking an adult GED class, and maybe this is something that your teacher is struggling to explain, I certainly welcome you to watch any of my videos, and please leave a comment below. Know that we're all in this together, and there's a lot of people out there that want people who are taking these classes to be successful. So anyway, enough about that. So this is a class to talk about slope-intercept equation, the good old y equals mx plus b, which will hopefully go from being something that you may be confused about to something that you're actually looking forward to on the test. Because once you understand this equation, the questions that go along with it are just not that hard, and you can do them quickly and easily with 100% chance of getting them right if you understand them. So let's go through what we are going to talk about. So what we're going to talk about is what is this slope-intercept equation? And there are three concepts we're going to go over in this video. First of all, we're going to talk about how do you graph one of these equations on a coordinate grid by creating a function chart. That's an input, output, x, y chart. So we're going to do some of those. Next, we're going to look at how could you graph a slope-intercept equation without using an input-output chart. So this is kind of like level 2. And then finally, how can you identify the equation of a line on a graph just by looking at the line on the graph? And it is possible to look at that line on the graph and write the equation that would equal that line. And that's when you know that this is starting to get pretty easy for you. So those are our three concepts to get started. How do you, given an equation, make a graph on a grid? So it's very possible that you're going to be given an equation, and it might look something like this: y equals 2x minus 3. And that's a slope-intercept equation. It's in the form of y equals something times x plus something. So in this case, the 2 is the m, and the b is minus 3 or negative 3. Well, the simplest way to do this is by choosing a number of inputs to place for x. I always pick 0 because it's easy. I always pick 1 because it's easy. And then you could pick like a negative 1 or a negative 2. You could pick something like a 3. If you do this correctly, they will all line up, assuming that it's a normal equation. So when I say we're going to pick a 0 for x, what I mean is we're going to put a 0 in place of the x. So I'm going to do that down here. So I'm going to write y equals 2 times 0. So I'm putting this 0 in for the x. Okay, so x is the x column, x minus 3. And then I'm going to use my order of operations to solve it. So first thing is 2 times 0. Well, that is 0. And then 0 minus 3 is negative 3. So that means if I put a 0 in place of the x, my end result is that y is equal to negative 3. So one of my coordinate points, this becomes a coordinate point on my graph, is at 0 on the y on the x-axis. Remember, this is your x and this is your y. So it's at 0 on the x and -3 on the y. So right here is that point. That point is right here. It's one of an infinite number of points on the line. So now we're going to do the same thing, except instead of 0, we're going to put a 1. So now I'm going to write y equals 2 times 1 minus 3. So now we're putting a 1 for the x. And again, remember, we just pick these numbers. You can pick whatever numbers you want. And there's an infinite, there has to be an answer for every number that you can put in for x. So 2 times 1 is 2. So y is equal to 2 minus 3. And y is equal to 2 minus 3, so y is equal to -1. So if we put in a 1, we get out a -1. That means we have a coordinate point at +1, -1. So starting at the origin, we go +1, -1. You have a point right here. All right, let's do 2 more. What if we put in a -1? Well, -1 on the x is here. See what happens. And again, we are picking these. We are doing these because we feel like it. I'm going to do it up here this time. Y is equal to 2 times. Now for our x, we're putting in -1 minus 3. Order of operation says we do this first, the multiplication. 2 times -1 is -2 minus 3. Y is going to be equal to -2 minus 3. That is a -5. So if we put in a -1, we are going to get out a -5. Okay, well, that's fine. On our x and y axis, that looks like this. X is -1, y is -1, 2, 3, 4, 5, and we are right here. And you'll notice these points are lining up very consistently. Okay, so let's try something farther out on the x-axis. Let's try a 3. All right, here we go. Y is equal to 2 times 3 minus 3. Order operations, y is equal to 6 minus 3. Y is equal, 6 minus 3 is 3. So we have a coordinate point at 3, 3. So we would go out 1, 2, 3. We would go up 1, 2, 3. And now we have 4 points. And it looks like they're all lining up pretty well. As a matter of fact, if we were to make a line, and we were to draw a line through there, you'll see that all the points hit on a straight line. That straight line represents every possible number we could put in for x and every possible number that we could get out for y. Okay. So we have just graphed a line that is representing this equation. So this line represents all the possible solutions to this equation. All right. So let's clear this out. I'm going to get rid of this line. And we'll do at least one more. Now, this time, if after I write the equation, you would like to try it yourself, please do. Pick some relatively easy numbers. Don't make it crazy. Pick some easy numbers, put them in here. And if you have one that doesn't work so well, forget about it. Pick a different number. It doesn't matter. All right, so let's make up an equation here. Let's say y is equal, let's say it is -1/2. 1/2 x. We'll go +2 this time. Y is equal to -1/2 x plus 2. So now we got a little bit of a fraction thing going on here. So let's again pick some numbers, but this time we're going to look at this x. We're going to say, well, we're going to take half of x. So if we put an odd number in for x, we're going to get half of an odd number. We're going to get a 0.5. like half of 5 is 2.5. I'd rather not deal with that. So I'm only going to use even numbers here. But I'm going to start with a -2 to see what happens. I'm definitely going to keep my 0. I'll put in a +2 and I'll put in a +4. So a little bit of experience having done this for a while. I know that I want even numbers because we're cutting them in half. If you didn't do that and you started to get decimals, you could just forget about those numbers and try some numbers that are easier. All right, because remember, we get to make these up. It's fine, we do whatever we want to with them. So start off by writing our equation, y equals. We're going to start off with -1/2, and this time we're going to put in a -2 and then +2. So we're sticking -2 in place of our x substitution. But now we've got to actually do some algebra. -1/2 of -2. That's going to look like this. -1/2 times, and the question is, where does this go? Well, the -2 is the same as -2 over 1. Okay, you can put a whole number over 1 to make it into a fraction. Does not change the number. And then +2. So we've got -1/2 times 2 over 1. So 1 times 2 is 2. 2 times 2 is 2. Negative times a negative is a positive. We're going to get y equals 2 over 2 plus 2. Y equals 2 over 2 is 1 plus 2. Y is equal to 3. Now, there's a couple things going on here. Negative times a negative is a positive. You have to be able to multiply fractions. You have to know that 2 divided by 2 equals 1. But if you've got all that from your algebra skills, then you end up with 3. So we are going to have a point at -2, comma 3. So here's our point. -2 on the x is 2 backwards, and then up 3, 1, 2, 3, right here is our first point. Great. Does that mean we can draw our line? No. we need at least 3 points. Okay, technically you only need 2 points for a line, and I know people will say, well, I don't want to do extra work, it's worth time. But if this is the way you're doing it, you want to do 3 just to make sure that you've got the right answer. So we're going to stick 0 in for x. This is going to be easy because y equals 1/2 times 0 plus 2. Well, that's going to be 0. So y equals 0 plus 2 is going to be 2. So now we have a point at 0, 2. So back and forth 0, up 2, back and forth 0, up 2. Okay, x, y on the coordinate grid. We've got 2 points. Now, could we draw a line? Yes, we could. We don't want to do it yet, though. We want to make sure that we've got at least 3 points in the line. So let's do +2. Hey, you know what? Let's just jump down to +4. Y equals -1/2 times 4. So -1/2 of 4 plus 2. Okay. 1/2 of 4, 1/2 times 4 would be 4 over 2. So it's going to be negative. So we're going to get 1 times 4, -4 over 2 plus 2. Next step, y is equal. Well, -4 divided by 2 is -2 plus 2. This becomes -2 plus 2. Y is now equal to 0. So when we put in a 2 for x, we get out a 0 for y. Okay, so we go over 2, and we get a 0 for y. Now, this is one of those cases where if I'm in class, I go over 2 and I get a 0 and something is wrong. Something's wrong because this does not make the line. So we're going to look back and we're going to check and say, okay, wait a minute. What happened? Okay. And we're going to check our work. So we put in a 4 for x. That's right. Negative 1/2 of 4 is -2, right? That seems right. -4/2. 4 divided by 2 is 2. -2 plus 2 is 0. This feels okay. Oh, but then look what I did. So up on my chart, I put the answer in the wrong place. And this is the kind of thing that will get you. Now, that was an honest mistake. I didn't set that up. I wish I was that smart, but it happens, right? So I went 4 and got 0. I put a 4 in. I did not put a 2 in. So my dot is actually at 4, 2. Oh, look at that. Look at that. It makes way more sense. Way more sense. Now, just because I messed that one up, let's go back and do 2, because stuff happens. All right. Y is equal to -1/2 of 2 plus 2. Y is equal to -1/2 of 2 would be -2/2 plus 2. Y is equal, this is -1 plus 2, plus 2. Get that fixed. There's -2, 2 divided by 2 is 1, -2 divided by 2 is -1. -1 plus 2 is +1. So if we go over 2 spots, 1, 2, we go up 1, and there we go. And once again, we are right in line with everything that we're supposed to be. And there is that equation turned into a graph of all the possible x values that could ever be. All right, so every one of these points on this line would be an x value that you would get depending on what you put into the equation. Okay, so that is graphing using a function chart or an input-output chart. And anybody can do this. And it's a great way to know if a coordinate point is on a certain line. Going into the next question, remember what our next question was: how to graph a y equals mx plus b equation without using a function chart. So there is a way to do this without a little bit of that work. But in order to do that, you have to know in the formula y equals mx plus b. Now I'm going to shrink this down just a little bit here. In the formula, y is equal to mx plus b. If you know what each one of these stands for, you can actually graph the equation without doing inputs and outputs. So this is kind of a level up. So first of all, let's go over these 4 questions. What do the x and the y represent? Well, what does an x and a y stand for? I'll give you a hint. This is x, and that's y. So the x and the y, they stand for a coordinate point. And we just did that. You put in an x, you got out a y, that became a point on the line. So the x and the y represent a coordinate point on the line. Okay, so the b and the m. We're going to figure this out because what we're going to do is we're going to write a simple equation, and then we're slowly going to change the b or the m a little bit just to see what happens. So let's start with a simple equation. Y is equal to 2x plus 1. Nice simple equation. We can do these pretty much in our head. We're going to use an XY chart, and we're going to figure out what happens and where this line is. So we're going to use the original way we're going to do this. Let's put in a 0, let's put in a 2, let's put in a 5. 0, 2, 5 should be great. If we put in a 0, y equals 2 times 0 plus 1, we are going to get out a 1 because 2 times 0 is 0. 0 plus 1 is 1. If we put a 2 in place of x, 2 times 2 is 4 plus 1, we're going to get out a 5. Uh-oh, that got big pretty quick. If we put a 5 in for x right here, that's a 5. 2 times 5 is 10 plus 1 is 11. Now we're going to try to graph these. So 0, 0, 1 is right here. That's not a big deal. 2, 5 is over 2, up 1, 2, 3, 4, 5. That's okay. But 5, 11 would be 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be like up here. So it's not on our chart. So maybe we want to try something that's a little bit smaller. Well, it looks like this line's coming down here. So let's try like a -2, -3. Let's just go -3. 2 times -3 is -6. So if we put a -3 in here, 2 times -3 is -6 plus 1. -6 plus 1 is -5. So we're gonna have a point at -3, 1, 2, 3, down 1, 2, 3, 4, 5, -3, -5. And now when we draw our line from about here down to there, we put them on a line, there's our line. So what we're going to do now is we're going to change one thing. And we're going to start looking for correlations, things that you start to notice, all right, clues in a way. So instead of 2x plus 1, we're going to change it to 2x plus 3. And we're going to redo our chart. And we're going to draw the same line. Now we're not changing anything over here. We're only changing this b, this plus number or minus. It can be a minus number too. So x, y, make our little chart. This also gets us better at doing this, which is using a function table to graph an equation, which is a great skill to have. And we're going to use some numbers. So again, I'm going to start off with 0. At this time, I'm just going to wait and see what 0 does. So if I put y equals, let me get rid of that. Y equals 2 times x plus 3, and we put a 0 in for x. If I put a 0 in for x, I'm going to get out of 3. Now I'm going to graph this point right away. So 0, 1, 2, 3. Notice that it hits on the y-axis. Because if 0 is x, that means I don't go left and right. I put in a 0, it wipes out whatever this m is. This m doesn't matter. This 2 could be whatever. It doesn't change anything. So let's put in a 1. 2 times 1 plus 3 is 5. And let's put in, say, -2. Let's go the other way. 2 times -2, -4. -4 plus 3 is going to be -4 plus 3 for -1. Again, you can use a calculator for that if you want to. So we also have a point at +1, +1, 2, 3, 4, 5. And we've got a point at -2, -1, -1, 2, -1. And now we've got 3 points. And with these 3 points, we can probably create our line. Now I don't want to, you know what, let's get one more up here so that I can make sure I've got a straight line. Let's see if I go to 3. Let's go to 3 and see what we get. 2 times 3 is 6 plus 3 is 9. Okay, that's still on the grid. So we're gonna have a point at 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 up right there. Now I feel good about drawing this line. I'm gonna draw this line down through the other lines. And what do we get? We have a line with the exact same angle or slope, but it's going through a different point on the y-axis. So if I were to grab this, now it might not be perfect, but it's pretty close, right? It's the same slope, but it's going through the axis at a different point, or you could say it is intercepting the y-axis at a different point. Now this was y equals 2x plus 1. And this line is y equals 2x plus 3. It's time to draw a conclusion here. Look at that plus 3 and look at where this, I'm going to change colors here. Let me just pick so I can say red line, blue line, or red line, black line. All right. So this with the plus 3 is going through the y-axis at 1, 2, 3. So looking at this right here, that plus 3, and the y-axis is going through at plus 3. This equation, which was y equals 2x plus 1, is going through the y-axis at plus 1. Because when we put a 0 in for our x, it eliminates the number in front of the x because 0 times anything is 0. All we're left with in our equation is whatever that plus number or minus number is. And that is our intercept. And the intercept is the letter B. So let's try one more time, except now we know what we're looking for. Let's say that our plus b is actually a minus 2, but we're going to keep everything the same, 2x. And you could either say plus negative 2 or just minus 2. It really doesn't matter. Because adding, oh, that was weird. Y equals 2x minus 2. Because adding a negative and subtracting are the same thing. So now we're going to set up our x and our y. We're going to try to do it a little neatly. So here's our x, here is our y. And now we're going to pick right here. I want to hit negative 2. So let's put in some things. First thing we're going to put in 0. If we put a 0 in for this x, 2 times 0 is 0. Then we get minus 2 for our y. So that is a correct point. 0, negative 2. Let's put in a positive 3. So if we put 2 times 3 is 6. 6 minus 2 is 4. So we put in a 3, we get out of 4. So if I go over 1, 2, 3, I'm going to go up 1, 2, 3, 4. I have a point right there. Interesting. And now we're going to go with, let's go out farther. Let's go out to 6. 2 times 6 is 12. 12 minus 2 is 10. So we would have a point at 1, 2, 3, 4, 5, 6, up 10, which is the whole way up to the top of the grid. I got a point right there. And now we check our line. Start it. We're going to take it down through there. And look at that. Now I moved a little bit again. It's not perfect, but it would be if we were doing it on a computer. And here we are, right? Get rid of that. Okay. So again, we have the same slope, not perfect because I'm doing it by hand, but this one was y equals 2x minus 2, and look at where it goes through the y-axis. So the slope-intercept equation, what does the b represent? It's the y-intercept, which means where it crosses the y. So we could look at this right away and know that we're going to cross right here. We could look at one of our other ones, y equals 2x plus 3, and we know that that line is going to cross at positive 1, 2, 3. And we could have looked at this one right here, y equals 2x plus 1, and know that it's going to cross at 0, 1. So the b is the intercept. The x is the x coordinate. The y is the y coordinate. What's the m? So we need to figure out, okay, so what is this m then? Well, we're looking for the slope intercept equation. We found the intercept. We're done with that. That is the b. So the slope, the only thing that's left is the m. All right, now to do this one, I'm going to do some new equations. I'm going to get rid of all this stuff. So we're going to clear all this out. We're going to pick some new equations. We're not going to use the same ones. Delete and delete. And nope. No. There we go. Okay. So we need to come up with an equation. I don't want them all cramped together. So let's say y equals. Let's go back and do something. We're going to keep it simple. All right. So we're going to do 3 times x minus 1. Now let's use what we already learned. We already know where one of these points is going to be, because in our xy, if we put a 0 in for x, 0 times 3 is 0, minus 1 right there, that is our y-intercept. So I know that 0, negative 1, right there is going to be one of the points on my line. I can do that just by looking at this. I don't even need to do this. But now let's take a look. Let's put in a couple other letters, numbers, and see what we get. Let's put in a 3. Let's put in a 1, and let's put in -2. And let's see what this line looks like. So if we put in a 3, 3 times 3 is 9. So this would be 9. 9 minus 1 is 8. So if we input a 3, we get out an 8. If we input a 1, 3 times 1 is 3. 3 minus 1 is 2. So 1, 2 is going to be a coordinate point. Now -2. 3 times 2 is 6. 3 times -2 is -6. -6 minus 1 is -7. So let's plot these 4 points. We already have this one. Let's plot 3, 8 over 3. 1, 2, 3, up. 1, 2, 3. 4, 5, 6, 7, 8. Right there. That's 3, 8. 1, 2 over 1 up to -2, -7. 3 times -2, -6, minus 1 is -7. So -1, 2, -1, 2, 3, 4, 5, 6, 7. Okay. Now we're looking for something that makes sense with this number right here. We're trying to figure out, how is that number 3? How can we see that represented? Because we could see, now we can also do a little extrapolating here. We could say, well, I bet we could figure out where +2 is. 3 times 2 is 6, minus 1 is 5. I bet there's a point at 2, 5. Let's see if that makes sense. So 2, 1, 2, 3, 4, 5. Oh, that makes perfect sense. Look, it's right in there. Now, if you look at this, you can hit pause. I bet you could figure out another coordinate point that has to be somewhere in between 0 and -2. Well, it would be -1, right? But where's the -1 going to end up? Well, it's going to be right in between these two. So if we put 3 times -1, -3 minus 1 is -4. We got a point at -1, 2, 3, 4, and look at that. Falls perfectly on the line. All right. So what does this tell us? It's still, I bet a lot of people are looking at this and be like, well, where are you getting 3 from? Where does this 3 come from? All right, step 1. This can be a fraction. This could be 1/2. This could be 2/3. Could be 4/3. Could be an improper fraction. It could be a lot of things. So let's rewrite this as a fraction. Y equals 3 over 1 x minus 1. So we're just rewriting this 3 as an improper fraction. Can you see anywhere, looking at that line, where we are going in seeing numbers 3 and 1. Let me try to get this lined up right. Well, if you haven't seen it yet, I will show you something. Let me change colors here. Go to red. Keep it thin. If we look from point to point to point to point to point, as we are going from this point to that point, we are going over 1. Okay, we're going over 1. And from this point to that point on the X, we're going over 1. And from this point to that point, we're only moving over 1. But we're going up 3. So this point to that point, we're going from -7 to -4, and then to -1, and then to 2, and then 2 plus 3 is 5, 5 plus 3 is 8. So we are going up 3 and over 1, and we're going up 3 and over 1, and we're going up 3 and over 1. Now, it's not going to look quite as nice, but I'm going to do this with by hand. So when we are going from one point to the next point, we are going up 3 and over 1, and then up 3 and over 1, and up 3 and over 1. And now when you start looking at this improper fraction, you see that the top number is how far we're going up or down. And then the bottom number is how much we're going over. So a slope of 3, which is really 3 over 1, that 3 tells us, hey, from each point to the next point, just go up 3 and over 1, up 3 and over 1. And you see, what are we making? We're making a set of stairs. We're making a staircase. But we are going up 3 and over 1 for each step. So up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. So slope on your GED, what is that got on there? Slope on your GED equation sheet is defined as y2 minus y1 over x2 minus x1. Now that is a very fancy way of saying the change in your y over the change in your x. So I like to write this as, I put a triangle, change in y, so that stands for the word change. Change in y over the change in x. Now, I want you to take a second, write that down, or get out your GED sheet. I have one sitting right next to me over here. Take a look at that. y2 minus y1 over x2 minus x1. Now, I'll do a whole separate video about this because you can go really in depth with what slope is. But for our purposes right now, it's how is the y changing over how is the x changing. So here our x is only changing 1 from point to point. It's going over 1, going up 3. So up or down 3 over 1. That's what I want you to focus on right now. The top number of the improper fraction is how's the y changing, the up and down, and the bottom number is how is the x changing left and right. So we're going to come up with another equation, and we're going to graph it, and we're going to see what it looks like compared to this. So let's get rid of that. Goodbye, ink. Now, unfortunately, I was doing these line things. Let's see if I can select them and get rid of them. Oh, that got rid of my line. I did not actually want to get rid of the line. I want to leave that there. So Let's just do it the old-fashioned way. Delete. Hopefully I'll have time to edit this out, but if not, this happens in class. So like I said, this is like a real class. Just for you, my dear viewer. All right, we're gonna put this back. Now that was, let's see if I can remember what it was. It was a slope of 3, and it was a slope of 3 minus 1. Minus 1. There we go. That's about right. All right, so this slope here was y equals 3x minus 1. Okay, so let's do a different slope. Let's do a different line, see what we can do. All right, so let's do y equals, instead of 3 over 1, let's do 1 over 3, 1/3 x plus 3. 1/3 x plus 3, lots of 3's going in here. So first thing, the y and the x represented coordinate points. Okay, that represents the address of a point. The b represented the intercept. So let's take care of that point first. Let's change to a different color. Got all these colors. Why would we not want some different ones? Okay, so we're going to do purple, and we're going to do it in thin line. So we can already say, look, I know that if I put a 0 in for my x, I'm going to get out a positive 3 for my y, because 1/3 of 0 is 0, and 0 plus 3 is 3. So I know that this new line is going to cross at 0, 1, 2, 3. So I know this is a point on my new line. And this is, the old math person saying, okay, well, I know I'm going to be dividing by 3. So it's going to be 1/3 of x. I want to pick numbers that divide by 3. So I'm going to take -3. I'm going to take positive 3, and I'm going to put in a 6. That's a positive 3. Okay. 0, -3, 3, and 6. So when I do this next one, 1/3 times the magic of my brain, I can say 1/3 and write 1/2, is truly a miracle. 1/3 times -3 plus 3. So 1/3 of -3. That is going to be 1 times -3 over 3, which is going to be y equals -3 over 3 plus 3. Okay, -3 divided by 3 is 1. 1 plus 3, well, it's -1. 3 divided by 3 is 1. -3 divided by 3 is -1 plus 3. That's going to equal -2. So we're going to have a point at -3, -1, 2, 3, -1, 2. -3, -2. Let me make sure. -3 plus 3. Oh, it's not -2. I felt something was off there. Oh, maybe you caught me. You caught me. Good for you. -3. If this is -3, -3 divided by 3 is -1. -1 plus 3 is a positive 2. So that point, we would have quickly found out that one's in the wrong place. So let's go -3. 1, 2, 3, positive 2. There we go. That makes much more sense. All right. Let's try another number in here. Might be able to do this in our heads. We'll see. 1/3 of positive 3. 1/3 times 3 is 1. 1 plus 3 is 4. So that means if I go out 1, 2, 3, and up 1, 2, 3, 4, positive 3, 4, that's another point. Now let's try 6. If we go y equals 1/3 times 6 plus 3, 1/3 of 6 would be 6 over 3, which would equal 2 plus 3 is 5. So if I go out 1, 2, 3, 4, 5, 6, and up. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. There we go. Now, again, I could put other numbers in here, but I know when you're dividing or multiplying by a third, you want your numerator to be something that divides evenly by 3. Now we've got a line. We've got a line going right here. I'm just going to extrapolate that a little bit. I don't know why it's a red line. I would much rather have that be a purple line. You know, let's make that purple. Okay. So now we have an equation. That is y is equal to 1/3 x plus 3. 1/3 x plus 3. It's crossing the y-axis at the positive 3. That part's easy. Look at it. Plus 3, plus 3. 1, 2, 3. It's crossing at 3. No problem. However, what we're looking at is slopes. So we're looking at right now a slope of 1/3. Now, I said that the top number was the change in y being the up and down. So change in, he goes over there, change in y is 1. The change in x is 3. So from point to point, or from anywhere on the line to anywhere else on the line, it's going to go up and down 1. Now it's positive, so positive is, good grief. So positive is up. So it's going to go up 1, because this is positive, this is negative. And the 3 on the bottom, positive, negative. It's going to go over 3, but it's positive 3, so it's going to go up 1, and then it's going to go over to the right 3 spaces. So up 1 over 3. So let's just look. If we start here and we go up 1, and then we go over 1, 2, 3, we are right back on the line. So up 1 over 3, back on the line, up 1 over 3, back on the line. And you can see every time, now I could go backwards 3, 1, 2, 3, and down 1, and I'm back on the line, and that would be a point. Or I could go another up 1 over 3, and I know it's going to hit right there. So this slope is all about how much are you going to go up or down, and how much you're going to go over. And that tells you where your next point is. And then you can reverse it to go the other direction if you want to. So the slope intercept equation, what does the m represent? The m represents your slope. Now we've got one more question. What if your slope's negative? So we need to answer that. If you haven't taken a break yet, hit pause, take a break. This is a lot. And you'll need practice to get better at this, but trust me, once you get this, you will love seeing these questions. So we're going to do an equation. Y equals negative 2x plus, we're just going to keep it simple, plus 4. Okay. We're going to do the same thing here. Set up our x and our y input outputs. Now we already know this is going to go through at positive 4. So let's change to a new color. 1, 2, 3, 4. I know it's going through right here. Okay, I know it because that is the intercept. Or the B. Remember, y equals something times x plus or minus, put a minus on there, plus or minus a number. Okay. Y equals negative 2x plus 4. Now, negative 2. If we look at that, just this right here, with what we learned, negative 2 as an improper fraction would be negative 2 over 1. Which means, if that's the up or down, okay, that's the up or the down, and this is the left or the right, we are going to go down 2 and then over 1. So from here to here, now we're going to try to predict this out before we actually put in our points. I'm going to count down 1, 2, and over 1, and I'm going to put a point. Then I'm going to count down 1, 2, and over 1. I'm going to put a point, down 2 over 1, down 1, 2 over 1, down 1, 2 over 1, and I can already see my line, 1, 2 over 1. Not only can I see my line, I can see exactly where it's heading. Now, if I want to go this direction, I have to reverse it. So instead of down 2, I'm going to go up 2, but then I'm going to go backwards 1. So I'm going to put the negative sign down here. So I'm going to go positive 2, negative 1. So I go positive 2, negative 1, positive 2, negative 1, positive 2, negative 1. And I believe I can do one more down here. That looks like a pretty straight line. And I can take that and I can graph that line from here to there. It should be perfectly straight. And I didn't have to do any of this. Yay! All right, so this takes practice, but let's go ahead and do it now. All right, let's do some and just see, are we right? Or am I making this whole thing up? I could just be making a spoof video. Like, guess what? Math's not easy. No, it's actually impossible. No, just kidding. It's going to work. I promise it'll work. So negative 2 times 0 is 0. You would be left with 4. So you'd have a point at 0, 1, 2, 3, 4. So this one, we just checked. That one's good. Let's go out. Let's go out 2. 2 to the right. Negative 2 times 2 is negative 4. Negative 4 plus 4 is 0. So we should have a point at 2, 0. We go out 1, 2, we go up and down 0. That would be that point right there. All right, let's throw a negative number in. Let's go negative 3. Negative 2 times negative 3 is positive 6. Plus 4 would be 10. So we should have a point at negative 3, 10. Let's check. Negative 1, 2, 3, all the way up. We know that line's 10. It's right there. Boom. Check one more. I don't know. We did 2. We'll do 3. Okay. Negative 2 times 3, negative 6. Negative 2 times 3, negative 6, plus 4, negative 6 plus 4. Think about it. It might be faster than I am, but I think it's negative 2. Negative 3 times negative 2 is negative 6. Negative 6 plus 4, negative 2. So we would go over 3 down 2, over 1, 2, 3, down 1, 2, and it's right there. So we can graph this equation without plotting a single point because of knowing how to do the slope and the intercept. So the M is the slope, the B is the intercept, X, Y coordinate point. And now you've got the foundation. So let's answer this last question though. What's the difference between this last one, where we had a negative slope, and the other two where we had positive slopes. Because remember, this slope was up 1 over 2. That was a slope of 2, or 2 over 1. This line was up, if we go from a point where it crosses 1, 2, 3 over 1, that was a slope of 3, or 3 over 1. And this slope here was negative 2 over 1. So if this one, the slope was 3, this one, the slope was 2, this one, the slope was a negative 2, what's the only difference between this line and this line and this line? Well, okay, pretty straightforward. This line, as you go from left to right, this line is going up. Up is considered the positive direction. As you go from left to right, this line is going up in a positive direction. However, our third line, as you go from left to right, this line right here is going down, which is considered a negative direction. So down is negative, up is positive. Anytime you have a negative slope, your line from left to right is going to go down. Now, it might not be quite as extreme as this one. This one goes down pretty hard, but it's going to be going in a downward direction. All right, so the M, last time, slope. How does a negative? Negative goes down from left to right. The B is your intercept on the y-axis. Okay, X and Y represents a point on the line. So you got a point where it intercepts the y-axis, the slope, and whether or not it goes up or down. If it's a positive, it goes up. It's positive, it goes up. It's negative, it goes down. All right, now, final test. Here you go. The next page. We're almost done. I've got 4 lines on this graph. This is your challenge. Looking at these equations, which of these equations represents which of these 4 lines? Now, if you can do this, and you couldn't do this before, you have really learned something. Please leave a comment down below. I'm going to pause the video. No, I'm not going to pause the video. You're going to pause the video. You're going to try to put the color of the lines into those boxes. So match up the equation with the line, and then hit play again. And I will go through the way I would do this and the way I would think about it. But let's see how many you can get right. You should be able to get all 4, but take your time. Really think through it. Look for the clues. Okay? So, hit pause. I'm about to give the answers. All right. Hopefully you took some time. You really looked at this, because this is very much like what you're going to see on the GED. They're going to give you a line. They're going to give you which of these equations matches line A, which of these equations matches line B, something like that. So here's what I want you to do. Step 1. Okay, I'm going to go to red ink. Step 1. I want you to look at where the different lines cross the x-axis. So actually, I'm going to pick a color that we haven't used yet. We got black, blue, green, red. Yellow doesn't show up very well. Lime green would be okay. Oh, you know what? This yellow will show up fine. Okay. So I want you to look at where does this cross the line. So the blue, oh, it doesn't show up. Darn it. Go to orange. There we go. So the blue is showing up at +2, 1, 2 above. The green is hitting at about 1 above 0. The black line is hitting at 0. And the red line is hitting way down here at -1, 2, 3, 4. at -4. That's it. You're done. You're done. Because look, we're looking for a -4. We're looking for a +1. We're looking, this has nothing. There's nothing after the mx. There is no plus b, which means that the b has to be 0. And there's +2. So you can already say, well, the b or the intercept on the blue line has to cross at +2, so blue has to be here. Which one crosses at -4? Well, it's the red line. Red line crosses at -4, so that has to be there. Which one crosses at +1? Well, the green line crosses at +1. So that has to be there, and that means black has to be here, because black crosses at the origin point. We're done. We already identified all 4 of these lines and what their equation is. Let's say we didn't think of that though. Let's say we didn't think of that. Let's just look and say, all right. Hang on, that was too, oh my goodness, get back up there. What are you doing? Let's say that was too much, too easy. We don't want to make it that easy. So let's just rule some things out here. All right. Well, from left to right, the green and the blue line are going down, which means the green and the blue line have to have a negative slope. So either this is green or blue, or this one is green or blue. But we know that if I have a line that from left to right, it's going down, this is negative, and this one's negative, because from left to right, this one has a very, very hard down slope. That means that red and black have to be positive. So the red and the black are either this one or this one, just by whether or not their lines are going up or they're going down. Okay, so we've already eliminated, this is red or black, this is green or blue, red or black, green or blue. So we've kind of limited things down. Now we could obviously go to the intercept to figure it out, because this one's a 0, that's -4. So again, we could do that. But let's say we forgot about that and we're just trying to do slope. We're just looking at this number in front of each one of our lines. So 2, a slope of 2 is a slope of 2/1. That means because it's positive, it's going to go up 2, it's going to go over to the right 1. So we could look at any one of these, and I'm only looking at red and black because it's positive. So if I go black and I find a point where this line hits exactly on the grid, and then I find another point where this line hits exactly on the grid, and I say, I want to go from this point to that point, I can go up 1 over 3. So up 1 over 3, which is up 1 over 3. I'm looking for a slope of 1/3. And now I know the black line is actually this one here. So I can get rid of this. I can put black. If I can find the right tool, I can put black in here. It's going up 1 over 3. The red, ooh, where does it actually cross? That's a good question. I think it crosses here. Doesn't cross there. It might cross there. Yeah, I think it crosses here. And then here. Okay, and then there. Yeah, my line's a little bit off, but it's basically going up 2 over 1, up 2 over 1, up 2 over 1. And that seems to be pretty consistent. Up 2 over 1. So up 2 over 1, up 2 over 1 equals a slope of 2. And now I've got that right there. Right there's my slope of 2. So I can move that red in there. All right, let's get rid of some of the writing here. So now we've gotten rid of the red and the black line. So to make this a little bit easier, let's actually just get rid of the red and the black line. So those were the 2 lines that were going in a positive direction. Now we're looking for slope of which one's green, which one's blue. Now blue's a little bit more extreme. Green's a pretty good slope. So we're looking for, where does it go through? Well, it looks to me like green just goes down 1 over 1, down 1 over 1, down 1 over 1. And it looks like it's keeping up this pattern all the way down. It's a 1-to-1, 1-to-1. So it's going down 1 over 1. So down 1 is -1. Over 1 to the right is still positive. -1 over 1 equals -1. -1 divided by 1. So we're looking for a slope of -1. I don't see a -1. -3, 1/3, -2. But you've probably run into this in your class. If you have a negative variable, that is the same as a -1 times the variable. All right, it's not 0, it's 1. So if you have -x, this is actually, that's actually -1x. We just don't bother writing the 1 because everybody assumes that we all know it. But -x is the same as -1x, which means the green line is right here. Right there's our green, which means this has to be our blue. Now, if that's our blue, it's got to go down 3 over 1, because that's saying that it's down 3. Oops, I need to get my pen back. Down 3 over 1. So let's check. I think it hits here. It looks like it hits here. It looks okay. It looks like about there. So we can check. Does it go? I'll check here because it's easier. 1, 2, 3 over 1. 1, 2, 3 over 1, and 1, 2, 3 over 1. Yes, it is going down 3 over 1, down 3 over 1, down 3 over 1. And we have the right slope. So -3x is down 3 over 1. That's the blue line. Hey, this takes some practice. Khan Academy, Kaplan, the Kaplan book, both great resources. Other videos, great resources. But honestly, get yourself a piece of graph paper. Write out a simple equation. Graph it. Then look at the equation compared to what you graphed. Look, see, did you get the right intercept? Did you get the right slope? The more you do and play around with this, the easier it's going to be, and the more you're going to look forward to having these questions. Real world application, handicap ramps, roof lines. All right. There's all sorts of places. Going skiing. What's the difference between the black slope? I think it's called diamond or something. I don't know. I don't ski. But there's all sorts of really, really important times where slope matters. And it is on the GED, which is why it matters directly to you right now. It's on your high school equivalency exam. I hope that this helped. If it did, please leave a comment. Let me know that you used the video. This was a long one. It's going to take a while to upload, but please let me know that it was useful. You can watch it and pause it and watch it and pause it. You can share it with a friend, or you know what? Give me a like. I don't think I've gotten any likes yet. But again, I don't expect, this is not a high-tech video, but if it helped you learn something, I would love to know that. And if any of my students watch it when you're absent, please sign in the comments, say, hey, Mike, I was here, I used the video. Thanks a lot. If there's some other math topic on the GED that you'd like a video on that is not on MathMiker, please let me know. I love making these videos. Even if they don't get a lot of use, I love doing them. So thanks a lot. Have a great day. And you know what? Persistence and resilience will get you there. You will pass your test. All right. Have a great day.